Problem A says each number in the input set is related in the same way to the number below it in the output set. So we have input and output. What is the rule for relating the numbers in the input, the numbers in the table? So, input and output tables. They use the words input and output. What that means is this number comes first, whatever number is in the input, and then it changes into the output number. So you can think of it as like maybe it goes into like a machine. The number that goes into the machine is 18, but the number that comes out is 21. So you're going to look for a pattern. When it changes from 18 to 21, is the number getting bigger when it comes out, or is the number getting smaller when it comes out? Okay. Well, it's not a yes or no question, Nakai. Is it getting bigger or is it getting smaller? Which one? Okay, bigger. So I'm going to put a B. It got bigger. Let's look at the next number. 39. So it changes from 39 into 42. 39 to 42. Is this number getting bigger or is it getting smaller? If it changes from 39 to 42. Bailey, is it getting bigger or is it getting smaller? It's getting bigger, so I'm going to put another B. It's changing. Okay, the next one. Number is changing from 80 to 83. 80 to 83. Is that getting bigger or smaller? Haley? Also bigger. Are you all starting to see a pattern now? Notice how all these numbers are getting bigger so far? We can check the last one and make sure that pattern continues. It changes from 57 to 60. 57 to 60. Does that number get bigger or does it get smaller? Jaylene?
Bigger.
Bigger again. So bigger, 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 bigger. Okay, I know all of my numbers are getting bigger. Well, now I have a question. Since this is math, I've got 4 operations that I could use. I have addition, subtraction, multiplication, division. 2 of my operations make my numbers bigger, and 2 of them make my numbers smaller. What are those operations that make my number bigger? Nakai?
I was gonna say I know what the answer is.
Oh, well, hang on for now.
Can I answer it though?
So, what do you think, Nakai?
What?
What 2 operations make my numbers bigger? That's okay. I'm not asking you something that's written on there. What 2 operations make my numbers bigger?
Adding and multiplying.
Adding and multiplying. So I know that whatever is happening to these numbers, it's either adding or it's multiplying. Yes, Christopher.
Can I answer it?
Hold on, Nakai. Yes, Christopher. What?
8, 80, and they're both getting bigger. I realize that 8, they must be getting bigger.
You're right. So what I do, once I know that it has to be addition or multiplication, I get rid of any answer choices that don't use addition or multiplication. Is there an answer choice that's not using the right operation that I can just get rid of right away? Which one can I get rid of? Can I get rid of A, B, C, or D?
B and D.
So is A using the wrong operation, Christopher? Didn't we say that multiplication makes numbers bigger? So multiplication isn't a wrong operation. Right now, I'm just getting rid of answer choices that are the wrong operation. Something that is not addition, something that is not multiplication. One of my answer choices does not use addition, does not use multiplication. Who can tell me what answer choice does not use addition or does not use multiplication? Bella. Subtraction. So I know for sure, it cannot be answer choice B. I've got 3 answer choices to check. Here's the important thing with these kinds of questions. Sometimes they'll put an answer choice that works for one of my numbers, but they use the word rule. If we say that something is a rule, it has to be fair for everyone. I can't make a rule that Ezekiel gets 100 on all of his tests and nobody else does, because that's not fair to everyone. That's a very good rule for Ezekiel, but it's not a very good rule for everybody else. So if it's a rule, it has to be fair for everybody. It has to work for everybody. So whatever answer choice I pick has to work for all of my numbers. Now, Nakai, you said you thought you found the answer. Which one do you think is our answer?
Because it's adding.
Okay, so I'm going to check and make sure it works for all of my answer choices. And if it does, I've got it. 18 plus 3. What is 8 plus 3?
1.
Alexa? 11. And if I carry over a 1, what's 1 plus 1? Alexa? 2. 21. Hey, if it matches, I put a check mark. So it worked one time. But just because it works one time doesn't mean I can automatically pick it. Let's check the next one. Nakai, you said this is right, so I'm going to give this one to you. 39 plus 3. What's 9 plus 3, Nakai?
11.
9 plus 3 is 11?
12.
12. Need to carry over a 1. And what's 3 plus 1, Nakai?
4.
4. 42. That matches. Got 2 check marks now. Okay, it's looking good so far. 80 plus 3. Christopher, what's 80 plus 3?
Easy. 83.
83.
0 plus 3 equals 3.
You got it. That matches. That's 3 check marks. Okay, one last one and I know I've got the right answer. 57 plus 3. What is 7 plus 3? Alexa, what's 7 plus 3? 10. Okay, so a 0. Carry over a 1. What's 1 plus 5? 6. 60. That matches. I've got the right answer. So good job finding that, Nakai. My answer was C. And I know it's the rule because it works for everything, not just one. All right, let's check out problem B. Look at each pair of numbers in the table. Again, we have input and output. Write the rule. Again, a rule. Can a rule be fair for just some people, or does a rule have to be fair for everybody? Bella? Everybody. It can't just be fair for one person. Write the rule that describes a pattern. Prove that the rule is correct for each pair of numbers. Okay, so first thing we need to figure out if our numbers are getting bigger or smaller. So input, output. These are the numbers that go in. These are the numbers that come out. 19 will change into 9. If 19 changes into 9, is that number getting bigger or is it getting smaller? Bella, what do you think? Bigger or smaller? Smaller, all right. 14 changes into 4. Nakai, is that number getting bigger or smaller?
Smaller.
Smaller again. All right, I'm starting to see a pattern. 21 changes into 11. Is that number getting bigger or smaller? Violet? 21 changing into 11. Is it getting bigger or smaller? Smaller. All right, let's see if it still stays. 12 changes into 2. Is it getting bigger or is it getting smaller? Alexa. Smaller. Okay, smaller, 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 smaller. I've got 2 operations that will give me small numbers. Who can tell me what those 2 operations are? Nakai, you're doing good with these. What do you think? What are my operations that give me smaller numbers? Division and subtraction. So I know that my rule has to either be division or subtraction. Let's try subtraction first. Whenever I have something like this, I'll be honest with you guys, I try whatever operation is easier. So that means I'll either try addition or subtraction first. If addition or subtraction doesn't work, then I switch to the tougher ones, the multiplication or the division. Okay? But always try the easier ones first. So let's try subtraction. 19. How much do I have to take away from 19 to turn it into 9? Okay?
9.
Okay, let me try. 19 minus 9. What's 9 minus 9?
0.
0. And 1 minus nothing is 1. So I got 10. So it's not minus 9, but it is close. What could I take away? Okay, 1 more. So I don't take away 9, I take away what?
10.
10. Okay, let's try 10. 19 minus 10.
Are we doing read aloud next?
Not right now, Christopher. Right now we're focused on math.
Or 0? You can't do that.
I can't take away 0? You can. Taking away 0 just means you take away nothing. So what's...
9 minus 1 is...
Now I get 9. Okay, so minus 10 worked one time. But again, if it's supposed to be a rule, can it just work one time or does it have to work every time? All right. So let's check. 14 minus 10. Who can help me do this one? 14 minus 10. Bella. What's 4 minus 0, Bella? 4. All right. What's 1 minus 1? 0. I got 4, and it matches. All right, I've got 2 matches. Let's try the next one. 21 minus 10. Who can help me with this? 21 minus 10. Who can help me figure that out? Jada, can you help me figure that one out? 21 minus 10. What's 1 minus 0, Jada? What would I get, Jada? 1 minus 0. 1. And what's 2 minus 1? 1. 11? 11. It matches. All right. It's looking really, really good. I've got one last one to try. 12 minus 10. Who can help me with 12 minus 10? Christopher. 12 minus 10. Help me out. What's 2 minus 0? Nope, just waiting. What's 2 minus 0, Christopher? I don't think Christopher's microphone is working. Who can help me out? Jaylene? What's 2 minus 0?
2.
2. What's 1 minus 1? 0. 2. That matches. It matched all 4 times. So what was the rule? What did I have to do? Nakai?
You have to subtract 10.
We had to subtract 10. But that was a good guess at first. 9 was really close. It was just 1 off. Okay. So these kinds of problems, it looks kind of confusing. It looks kind of scary. It's not. The first thing you do is you find the pattern. Are all of my numbers getting bigger? Or are all of my numbers getting smaller? Once you know that, you can figure out it's 2 operations, either addition and multiplication if your numbers are getting bigger, or subtraction and division if your numbers are getting smaller. And the last thing you do to make sure you have the right answer is it has to work for every single number. It can't just work for 1 or for 2. It has to work for all of them. Remember, rules are always fair to everybody, not just to some people.